Hello everyone. Graphs are a very useful structure in programming because often computer science problems can be represented as a graph and solved using one of its techniques. Even so, the field of graph theory is deep and fascinating. This video includes the minimum spanning tree. Before we learn about minimum spanning trees, we need to understand what a spanning tree is. A spanning tree is a subgraph of an directly connected graph that includes all the vertices of the graph with the minimum possible number of edges. If a vertex is missing, then it's not a spanning tree. There is a spanning tree example. A minimum spanning tree of a graph is a spanning tree with the minimum total weights. The figure shows the process of obtaining a minimum spanning tree. The problem of finding a minimum spanning tree has many applications. Consider a company with branches in many cities. The company wants to lease telephone lines to connect all the branches together. The phone company charges different amounts of money to connect different pairs of cities. There are many ways to connect all branches together. The cheapest way is to use spanning tree with the minimum total rates. How do you find a minimum spanning tree? There are several well-known algorithms for doing so. This video will be about the implementation of Prim's algorithm. Prim's algorithm starts with a spanning tree T that contains an arbitrary vertex. The algorithm expands the tree by repeatedly adding a vertex with the lowest cost edge coincident to a vertex already in the tree. Prim's algorithm and it's described in this. We find a vertex y in T that connects a vertex v in Vt with the smallest weight. The algorithm starts by adding the starting vertex into T. It then continuously adds a vertex from Vt into T. V is the vertex that is adjacent to vertex in T with the smallest weight on the edge. For example, there are 5 edges connecting vertices in T and Vt as shown in figure, and there is one with the smallest weight. Consider the graph in figure. The algorithm adds the vertices to T in this order. The adjacent vertices with the smallest weight are added successfully to T. A minimum spanning tree is not unique. For example, both C and D in figure are minimum spanning trees for the graph in figure A. However, if the weights are distinct, the graph has a unique minimum spanning tree. To make it easy to identify the next vertex to add into the tree, we use cost v to store the cost of adding a vertex v to the spanning tree T. Initially, cost s is 0 for starting vertex and assign infinity to cost v for all other vertices. The algorithm repeatedly finds a vertex y in Vt with the smallest cost y and moves y to T. This implementation of the MCT algorithm. The adjacency matrix representation of graphs is used in this code. This is a number of vertices in graph, and we create a two-dimensional array of size 5, 5 for adjacency matrix to present a graph. We create an array to track selected vertex. Selected will become true, otherwise false, and we set select false initially and set number of edge to 0. The number of edge in minimum spanning tree will be always less than vertex minus 1, where vertex is a number of vertices in a graph. Choose 0th vertex and make it true. Print for edge and weight. For every vertex in set S, we find the all edges and vertices, and we calculate the distance from the vertex selected at step 1. If the vertex is already in the set S, we discard it, otherwise choose another vertex nearest to the selected vertex. Well, talk about the advantages and disadvantages. The advantage of Prim's algorithm is its complexity. Therefore, Prim's algorithm is helpful when dealing with dense graphs that have lots of edges. However, Prim's algorithm doesn't allow us much control over the chosen edges when multiple edges with the same weight occur. The reason is that only the edges discovered so far are stored inside the queue. Also, Prim's algorithm is a little harder to implement. In conclusion, I want to say that the world of graphs in computer science is huge. Practicing skills for solving algorithmic problems, especially algorithms on minimum spanning tree, will help us to successfully pass technical interviews. Thanks for your attention.